is reached when the rate of forward reaction equals the rate of backward reaction and the concentrations of reactants and products remain constant.
You understand that? Don't
Mm-hmm.
say concentration of reactant and product are equal. Though. If I thought they are equal, that's a coincidence. What matters is that when reactant increases to a point, it does not increase again, it stays constant. When reactant decreases to a point, it does not decrease again, it stays constant. When products increase to a point also, it does not increase again, it stays constant. It's possible that the products and reactant have equal concentration. That is a coincidence. No, it's not always true. All that matters is that reactant and product reach a concentration that they are no longer changing. At that stage, we say they have reached a state of what? Dynamic equilibrium. Is that okay?
Yes.
Yeah, go on, please.
A closed system is required in order to establish dynamic equilibrium.
What's the meaning of closed system? A closed system is the one that exchanges only energy but not matter with the surrounding. A closed system, I'm not sure they have to define it, but you need to understand so that you can understand the concept very well. A closed system
Okay.
is what? Is the one that exchanges. Now look at it now. So there are three types of system. We have closed system. So this equilibrium note. You have systems. When we are system, what do you mean by systems? Now look at it. You have a beaker, and water is in it. If you leave it, let's say anyway, you put it there, it was initially 100 cm cube of water at 25 degrees Celsius. After like a week, you come back. What would the volume likely be?
It will be less than that.
Thank you so much. It will be less than, because some of them will have evaporated off. Am I right?
Yes, yes.
Temperature may be 25 may be temperature may be less. I mean, 25 degrees, or let me just say the final temperature may be less or greater than 25 degrees Celsius. Am I right? Maybe
Yes.
less. It will not make 25. What does that imply? That means this guy, there's an exchange of what? Matter and what? And energy. Do you agree? Some water
Yes.
has evaporated of exchange of matter. The temperature was no longer the one you put it there before. Sometimes it
Yeah.
increases, other time it falls. It does not remain constant. So what do we say here? There is an exchange of what? Matter and what? Energy. This is an open system.
Okay.
Now,
Yes, sir.
if I consider you as a system, what type of system are you to your surrounding? You are an open system. You know why? Sometimes you eat. Where do you get the food from your surrounding? You have
Yes.
some waste product from your body to where? To your surrounding again. Sometimes you feel cold, sometimes you feel hot. Based on do you get now? So you are exchanging both energy and matter with your surrounding. Do you agree to that?
Yes.
You get water from your surrounding, you drink it. That's matter. You say, everywhere is too hot. I want to go and shower. That means it's put into your body. You are feeling hot. That's it also. Is that okay? That's an open. So
Yes.
human being, we are open system. Now look at the closed system. Cover this. Seal it up. Seal it. Water is here. Can that be exchange if you come after 1 week? What will be the volume of the water after 1 week? It won't change because you cover it.
Volume.
So here, no exchange of matter. But can the temperature change or not?
Temperature changes.
Temperature of the water, can it change or it will remain constant?
It can change.
Thank you. So T can change. The volume of water, volume of H2O remain what? Constant. Do you agree? So that means there says, what do we say here? There is what? There is exchange of what? Of energy, but not exchange of matter. Do you agree?
Yes.
But no exchange of what? Of matter. That's the closed system. Now, what's an isolated system? The third one is isolated system. When you put water in vacuum flask, am I right? You put in a fragrant flask, such that maybe for like 1 hour or so, such that the temperature of the water remain constant. So yeah, no, this is isolated system. You agree?
Yes.
What does that mean? No exchange of matter, no exchange of energy. Do you get the point now? That's the meaning of that.
Okay.
No exchange of matter, one. Then again, what again? No exchange of energy.
Mm.
Is that okay? That's isolated system. But when we are talking about to get equilibrium is what? Is this guy closed system? You are not allowing water to come in or go out. Is that okay? And that what? Though temperature may change, but matter no change of matter. So we need a closed system to establish a dynamic equilibrium. Give an example of dynamic equilibrium. Give me an example that you know. Physical things, like look at it now. At 0 degrees Celsius, when you have ice going to water, if the temperature remains at 0 degrees Celsius, if it remains at 0 degrees Celsius, then this dynamic is also what? Dynamic equilibrium. The rate at which ice melts to water is the same rate at which water freezes back to ice if the temperature is maintained at 0 degrees Celsius. Do you get the point now? What else
Yes.
again? Water again going towards steam. If it is maintained at 100 degrees Celsius, there is a state of what? Dynamic
Equilibrium.
equilibrium. Rate of forward and backward are the same. Then the amount of ice and water don't change again. If the temperature is maintained at 0, if it's maintained at 0, it doesn't change. You have a thermostat. You put both ice and water, and you now lower the temperature to up to 0. If it's at 0, you have a mixture of water and ice. Both of them, they don't change. Some ice dissolve to water. Some water freezes back to ice. Is that okay? And the rate of going forward and
Yes.
backward will be constant. Is that okay? I know that.
Yes.
Next one. What is this principle? This principle guide us. Can you state it?
The Chatelier's principle states that if a change is made to a system at dynamic equilibrium, the position of equilibrium moves to minimize this change.
Hello, let me give an example. A baby is crying. When I say, stop crying, Joe, somebody shouted at him. So if you obey this rule, he will shout more. When you
Yeah.
want to make a change, the guy will counter it back and say, no, I'm not agreeing. Say, keep quiet. He say, I should keep quiet. He will not shout more. He will shout more. But when you make a change, the guy what does he do? He may reverse his position to neutralize the effect of the change you have made.
Okay.
Do you get the point now? He readjusts his to neutralize the effect of the change you have made. I'll give you another example. Maybe somebody say, I don't want to go to, I don't want to be reading again. You now begin to read more. You get the point now? You do the opposite of what you say you should do. You do the opposite. You counter the effect. Do you get the point now? That's just what happened there. Is that okay? We'll explain that
Yes.
later. Can you explain? Can you go on?
The change made could be a
Now,
change in
when
temperature.
you are reading it, hold on. When the
Okay.
change is made, that change made, what could it be? Yeah, go on.
The
Be a change
change
in
made
what?
could be a change in temperature,
Thank you.
concentration, or pressure.
Yeah.
These are the factors affecting the position of equilibrium in a reversible reaction.
Reaction is a reversible reaction. We are not saying that if you now, okay, good, I got that. This is a good example. At 0 degrees Celsius is both ice and water. What can I do to make more water? What can I can manipulate what? I can manipulate what can I manipulate? I can
The,
manipulate what?
the
Temperature,
temperature.
pressure, or what? Or concentration. When you
Uh-huh.
move to water side, you are favoring forward reaction. If
Uh-huh.
you move to the right, you can say you move to the right, you favor the formation of water, or concentration of water will increase, or it favors
Yes.
forward reaction, or yield of water will increase. They all mean the same thing. I'll say it again. Number one, if you move to the right, you are saying that you are favoring forward reaction, or concentration of water will increase, or amount of water will increase, or the yield of water will increase. Is that okay? So it's something about yield. Yeah, yield means how much will you get at the end of the day? Rate means how fast is it coming? But I talking about yield of reaction, or yield, not rate, yield. How much we're
You.
going to get. If we go forward, that means we are getting more of the product. If it goes backward, we are getting what? More of the reactant. Is that okay? Now,
Yeah.
this change about could be a change in temperature, in concentration, in pressure. These are the factors affecting the position of equilibrium in a reversible reaction. Now let's go. Can you read what next? Read what next?
Please note that a change in surface area, particle size, or use of a catalyst has no effect on equilibrium position.
A change in surface area, that's particle size, or use of catalyst has no effect. It does
Mm-hmm.
not affect. Equilibrium is like two people are in a tug of war. Are you there? Who
Yes.
wins? So the person on the right may win, the person on the left may win. What are the factors that will determine who wins? Temperature, concentration, and pressure. Is that okay?
Yes.
If you change some temperature, it moves forward or backward. Now let's see. Look at this now.
Mm-hmm.
Examples of equilibrium reaction. Look at them. Equation 1, 2, these are equilibrium reaction. I'll be defining all of them now. Now, what does this mean in terms of exothermic or no, I'm not talking, I've skipped the topic, but I know you understand it. This one,
Mm-hmm.
are they exothermic or endothermic? When enthalpy change of reaction is negative.
Exothermic.
Thank you so much. I like that. I know you understand. I know. So this one,
Mm-hmm.
what do you call them? Exothermic reaction. Am I right?
Yes.
What about this one from number 7?
Number 7.
7 to 12.
Those are endothermic.
Thank you. So those are endothermic reaction. So you know that I'll come back to all of them now. Let's start. Let's start
Okay.
using the Chatelier principle to reduce the effect of changes on a system at number 1, change in temperature. Can you read that?
For an endothermic reaction, an increase in temperature moves equilibrium position to the right, favors forward reaction, and produces a greater yield of the product.
All these three things mean the same thing. They are synonyms. Move to the right,
Mm-hmm.
favors for reaction,
Mm-hmm.
give more product. They are all the same thing. So these guys, they are all synonyms. They are synonymous. Synonymous. They are synonyms. Is that okay? Do you
Mm-hmm.
get now? If you understand that, let's go apply it. We have this equation 7 to 11. He said that when the forward reaction is endothermic, an increase in temperature moves equilibrium to the right,
Yes.
favors the product side, gives a high yield of the product. Is that okay? That is for endothermic, we need high temperature. Is that okay? So for endothermic reaction, we need high temperature to go to the right. Is that okay?
Yes.
All you need to remember, Tamuda. Let me teach you how to remember
Mm-hmm.
this. For endothermic to go forward, I need high temperature. That's all you need to remember. From there, you
Mm-hmm.
cannot reduce that. That means to go backward, I need what? To go
Less
forward
temp
for endothermic reaction, to go forward for endothermic reaction, do I need low temperature or high temperature?
to go forward.
Yes, to move to the right.
You need high temperature,
Thank you. That means to go backward, what do I need?
low temperature.
The reverse of that we now hold for exothermic. That's how to remember it.
Okay.
You don't mix them up. Don't try to remember all the four of them. You mix them up. Just remember that for
Okay.
endothermic, to move to the
Yes.
right, I need high temperature. That's all you remember. That's all you need.
Mm-hmm.
Therefore, to move to the left, you need what? Low
Low.
temperature. The reverse
Mm-hmm.
of that will now hold for exothermic. That means for exothermic, to move forward, I need low temperature. Is that okay?
Mm-hmm.
For exo to move backward, I need high temperature. Is that correct? Come back
Mm-hmm.
here. Reaction 7 to 12. If you increase temperature for reaction 9, what will happen to the concentration of CO2 at equilibrium? Reaction 9, if I increase temperature,
Mm-hmm.
the full
It's me.
reaction is extending. Don't forget, if I increase temperature, what will
Mm.
happen to equilibrium concentration of carbon dioxide? Will it increase or decrease?
It increases.
Thank you. Now, hello,
Mm-hmm.
reaction 7. If I
7.
decrease the temperature, This guy is called ester. This guy is called the ester you learn in your GCSE now. This guy is ester. This guy is alcohol. This guy is carboxylic acid. I'm just giving a general name for them all. I could have said carbonic acid, ethanol, ethyl ethanoate, and water. I could have said that. Now, equation 7. If I lower the temperature, what will happen to the concentration of ester?
It will decrease.
Thank you so much. Because we have said that for endothermic to go forward, we need what? We need high temperature. Is that correct? Now, come back. This equation, this one are exothermic reaction, all of them. For equation 2, if I decrease the temperature, what will happen to equilibrium concentration of ammonia?
Ammonia, it will increase because
Thank
it's a.
you. Because if they
it's
say why, just say that because forward reaction is exothermic. No story, just say that and go your way. 2 marks.
Okay.
Because forward reaction is what is exothermic. Is that okay? So for all exothermic reaction to go forward, we need low temperature. For all endothermic reaction to move forward, we need what? High temperature. Is that correct? To go forward means you are moving equilibrium position to the right. To go forward means you are favoring forward reaction. To go forward means you are producing a greater yield of the product. That is the effect of temperature. We are done. Number 2, effect of what?
Change in concentration.
Let me write this thing the way I wrote it. I think people don't understand this thing. Let me write it today. If you increase A, that square bracket means concentration. The square bracket means what? What does it mean? What does square bracket means? As in this, please, this means what? Concentration. I'll teach you use this topic. Is that okay? Square bracket means concentration. So if you increase the concentration of A, equilibrium position move towards A. Then equilibrium position move towards A. If you increase the concentration of A, equilibrium position will move towards A. If you decrease it, it moves. If you increase it, no, that's not true.
Okay.
I miss it. Stop. Sorry. Control C. Yeah, look at it. If you increase A, it moves away from A. If you decrease A, it moves towards A. If you try to increase A, the judge will say, why are you increasing A? It will now convert from A to B. Let's say B is the reactor. Let's say B is the product. Let's say B is the product. Is that okay?
Yeah.
If you try to increase anybody, the guy convert that guy to the other guy. If you increase, see, why do you increase A? Why do you have to do that? You will now convert from A to B to the product. What if you decrease A? It will now convert from product back to A to move towards A. Is that okay?
Yeah, that's fine.
Are you sure you get this?
Yes, I understand it.
Do this. We have other process. Look at other process. Number 2. If I add more hydrogen, where will it shift to?
It will shift to the right.
Therefore, equilibrium concentration of ammonia will increase. Is that okay?
Yes.
Let's go. What if I remove oxygen in reaction 4? I remove oxygen in reaction 4. What will happen?
If you remove.
If I decrease the concentration of oxygen in reaction 4, what will happen to the equilibrium position? Will it move to the right or to the left? Come and see it here. Look at it again. If you increase A, it moves away from A. If you decrease A, it moves towards A. A could be reactant or product. I don't care.
Okay, so it goes to hydrogen.
A, it moves away from A. If you decrease A, it moves towards A. A could be reactant or product. Is that okay? Don't forget that. You need to remember this.
Okay.
If you increase, if you, hold on, where's my pen? If you increase A, it moves away from A.
Mm-hmm.
If you decrease A, it moves towards A. When you are increasing A, the guy says, why do you increase A? He now converts from A. Look at it now. Look at it now.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Agile Tech do have a private tuition. So by my right, you can see that we have for the edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at agiletech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, um, and also for the edexcel. So we have for the Cambridge E levels and edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at agile@gmail.com, and they'll reply to you. And the good news about this is what I've discussed with the sales team is we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watch this in 2026, watch this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
Okay, good. We look at ice and water. If you increase amount of ice, the guy says, why do you have to do that? He now converts from ice to water. What does that mean? Moving away from ice. Is that okay?
Yeah.
If you add some ice, guys say, why do you add some ice? It will now convert some ice to water. But if you remove some ice, what will it do? It converts from water back to ice.
Mm-hmm.
It does what is opposite of what you are doing. You try to add more ice. Say, why do you have to add more ice? You convert some ice to water and say, let's go back to the status quo. Is that okay?
Yes.
If you add any substance, Equilibrium moves away from that substance by converting the substance to the other's product. Is that okay?
Mm-hmm.
Good. Now let's go now. Look at this.
Okay.
Reaction 9. If I do thermal decomposition in an open system such that carbon dioxide escapes, what does that mean? I'm decreasing the concentration of the carbon dioxide in the reaction mixture. Is that okay? If
Yes.
I do thermal decomposition of chapter number 9 in an open system such that carbon dioxide escapes, the escape of carbon dioxide means that I'm decreasing the concentration of carbon dioxide in the system, right? Equilibrium will move towards carbon dioxide. That means thermal decomposition will be favored. Do you agree?
Mm-hmm.
But now, look at number 9. See that number 9. If I add more calcium carbonate, where will it move to?
If you add more calcium, it will move away
Oh,
from it to the right.
thank you so much. When you add more, it moves away from him. Do you get that? Then you get that point. You can't mix stuff. Is that okay? But
Yeah.
now, I have a problem now. Now, look at, I want to show you something. Look at reaction 2. If I add hydrochloric acid, what will it do?
Equation number 2.
If I add hydrogen chloride or hydrochloric acid, what will happen? Pay attention to Mr.
Okay.
Hydrogen chloride is an acid.
Mm.
You will learn later that ammonia is a base. So the hydrogen chloride will react with the ammonia and remove ammonia out of the mixture. So
Okay.
addition of hydrochloric acid means you are decreasing ammonia. Do you get the point?
Yes.
So it should now move forward. Do you agree? So if you
Yes.
add hydrogen chloride gas, equilibrium moves forward. I'll do it another one. I'll do another one again. Now, see the equation 2. If I add water, only ammonia is soluble in water. That means concentration of ammonia will decrease. It should now move forward again. Do you get the point?
Yes.
If you add water, of all these 3 substances in equation 2, only ammonia is very soluble in water. Others are practically insoluble. What I'll do is that if I add water, all the ammonia will dissolve in the water. That means ammonia content will no longer be there. So adding water means decreasing the concentration of ammonia. Is that okay? And
Yes.
therefore, equilibrium move to where? To the right. Is that okay? Now look at this. Look at equation 7. Look at equation 7. If I add sodium hydroxide, which of them will it react with? Equation 7.
Sodium hydroxide. Would it maybe that? Mm,
Will react with the
acid.
carboxylic acid, with the acid. Is that okay? So
Yes.
addition of sodium hydroxide means decrease in concentration of the acid. Am I right? That's what it means. So equilibrium move to the back, move backward. Do you agree to that?
Yes.
When you add sodium hydroxide, it will single-handedly react with the carboxylic acid alone. Then the equilibrium will now move to the back because you are removing carboxylic acid. So addition of sodium hydroxide here means reduction of the concentration of carboxylic acid. Is that okay? Addition of sodium hydroxide means reduction in the concentration of what? Of carboxylic acid. Does that make any sense?
Yes.
So they may add some substances which can selectively pick one and not pick touch the other. Is that okay? So you know how to find a way around that. Is that okay? Do you understand
Yes.
those one very well? When we enter inorganic, you can apply inorganic care. Is that okay? I'm done with concentration effect. Go back to the pressure effect. Can you read, please?
Change in pressure. Pressure only affects equilibrium reactions involving gases and in which the moles of gases on both sides of equilibrium are not equal. For
On both
instance,
sides of equilibrium are not equal. Do you get that?
mm,
Yeah, let's go. Yeah, let's go there. Yeah, look at equation 1. How many mole of gas on the left? How many on the right? On the left,
4
4.
and
On the
4.
right, 4. So a change in pressure produces no effect on equilibrium position. Do you get the point now? The
Yes.
gas on the left hand must not be equal to each other. If it's equal, it won't make any sense.
Mm-hmm.
So equation 1, equilibrium has no, pressure has no effect on equilibrium. Why? Mole of gas on both sides of the equation are equal. What
Equal.
about equation 2?
4 and 2.
Pressure will have effect. Am I right?
Yes, it will.
That be pressure will have effect
Mm-hmm.
on equation 2. Is that okay? Now,
Yes.
high pressure favor the side that contains smaller molecules of gas. Is there? Look, I think I wrote it there. Yeah, can you read?
For instance,
Hold
pressure
on.
has. Okay.
Oh my God, I didn't write it there. I can't believe that. Can you read it? Can you continue reading?
For instance, pressure has no effect on the equilibrium position of reactions 1, 5, 8, and 10 because the moles of gases on both sides of equilibrium are equal. There is no change in the moles of gases from reactants to products.
Go on.
I can't see the first few words.
I didn't write this here before. Oh my God. Let me put it here. Oh, I didn't put it there, sha. Hmm, okay. I think it's okay. That is for the. Oh, let me take this guy up a little. Let me take it up a little. Let me bring this guy down. Okay, good. That's fine. This is fine. Can you see now? Can you
Yes.
read? Yeah, go on.
Also, pressure does not affect equilibrium position of reaction 7 since there are no gases involved. High pressure shifts equilibrium position to the side with smaller moles of gaseous substance.
Is that okay? Or smaller mole of gas. Is that okay? Now let's
Yeah.
go and see. High pressure, smaller mole of gas. Don't forget. High pressure, smaller mole of gas. Look at reaction 11. Where is the mole of, how many mole of gas on the left? Zero.
Wow.
On the right. On the left is zero.
Zero.
Yeah, ammonium
Oh,
chloride is a solid.
solid.
They put the same symbol there. 0 to 1. So high pressure to the left. Do you agree? Here, 1 to 2. High pressure move to the left. Here, 2 to 2. Pressure, no effect. Here, 0 to 1. No, 0 to 1. High pressure to the left. Here, 2 to 2. Pressure has no effect. Here, no gases. Pressure has no effect. Here, 0 and 1. High pressure to the right. Here, 2 mole of gas on the left, 2 mole of gas on the left, on the right. No effect. Here, high pressure. This is 3 to 2. High pressure to the right. This one, 2 mole of gas on the left, 1 on the right. High pressure to the right. This one, 1 plus 3, that's 4. This one is 2. High pressure to the right also.
You're
Can you see
right.
now?
Mm.
Are you sure you get all of these routes? I'm cleaning them, but you look rough, you are not cleaning them. Is that
Yes,
okay?
I understand.
The pressure will favor the side that contains smaller molecules of gas. Is that okay?
Yes.
So if high pressure favor the side that contains smaller molecule of gas, that means low pressure will favor the side that contains greater molecule of gas. Is that okay? Reaction that involve no gases, pressure has no effect. Reaction that involve gases and the mole of gas on both sides are equal. Again, pressure has no effect. For reaction 9, you have to assume that mole of gas on the left is 0, while mole of gas on the right is 1. Therefore, high pressure favor the side that has smaller mole of gas, which is the left. Therefore, high pressure shift equilibrium to the left. Is that okay? So what we favor
Yes.
the thermal decomposition of calcium carbonate in terms of temperature and pressure. Yeah. Number 9. What we favor thermal decomposition of calcium carbonate in terms of temperature and pressure? The answer is this. Number 1, the forward reaction is endothermic. Therefore, high temperature moves equilibrium to the right. Is that okay? That's number 1. Number 2, the forward reaction, the right hand side contain greater mole of gas. Therefore, low pressure will favor fall reaction. Do you agree? I've given answer to your
Yes.
question. Low pressure
Mm-hmm.
favors fall reaction. Then high temperature favor fall reaction. Is that okay? I'm done with that. You have applied the three principle. Catalyst has no effect on equilibrium position. Surface area, particle size has no effect on equilibrium position. Is that okay? Now let's
Yes.
go. Next one, equilibrium constant. Yeah.
Equilibrium constant in terms of concentrations, Kc. Kp equilibrium constant in terms of partial pressures.
Thank you. Yeah, go on.
The numerical value of K is only
K, then
affected
I
by
say
a
K, I
change.
mean KC or KP. Is that okay? Go on.
The numerical value of K is only affected by a change in temperature. A change in concentration, a change in pressure, and use of catalyst has no effect on the value of equilibrium constant.
Now, stop there. What are the factors that affect equilibrium position? Temperature, concentration, and pressure.
Mm.
Among these three factors, which one can affect the value of equilibrium constant? Only temperature. You get that? The
The
numerical,
value.
read it now. I wrote it here. Look at it from here. The numerical value of K is only affected by change in temperature. A change in concentration, a change in pressure, and use of catalyst have no effect on the value of equilibrium constant. Is that okay?
Mm-hmm.
Equilibrium constant has value. It can be 2.4, can be 8, it can be 50, it can be 10,000, it can be any value. Do you get the point now? Before the value
Yes.
can change, you must have changed temperature. The value don't change if you don't change temperature. When you change concentration and it moves to the right, it won't change. Change pressure, it moves to the left, it won't change. The only thing that changes value is what? Is temperature. Do you get that now?
Yes.
Now look at equation 4. Look at equation, let's go and see equation 4. Look at equation 4. For 4, what will be the KC? So look at K, we have seen 4 now. 2SO3
Yes.
on the product, 2SO2 and O2. So look at equation 4. This is the KC. KC is concentration of the product. Because of the 2SO2, it becomes square. These two here becomes a power. These two here becomes a power. This two also becomes a power. So it will be now, let me write here. Kc will be concentration of SO3 raised to power 2 because of these two, right?
Mm-hmm.
Over concentration of SO2 raised to power 2 into concentration of oxygen. That's right. Is that okay? Just the
Yes.
product, the coefficient of each of the substance now becomes a power. Is that okay? 2
Mm.
so now becomes a power. Is that okay? Am
Yes.
I communicating?
Yes, sir.
So when you're writing Kc or Kp, you cannot involve solid substances. You know why? Kp is in terms of concentration. A solid that is not dissolved cannot have concentration. Do you agree? So you can't
Mm-hmm.
involve solid substances. Kp is in terms of partial pressure. A solid cannot be compressed. It cannot have pressure. So when you are writing Kp, you involve only gases. When you are
Mm-hmm.
writing Kc, you involve both aqueous and gases. I'll write that here. I'm not sure I wrote that there. Kc, yeah, let me write it here. This one involves what? Involve gases and what? And aqueous, no solid. How about this one? Involves gases what? Only. Do you get that? Are you there?
Mm-hmm. Yes,
Thank you.
sir.
Thank you. Now let's go on. So look at the way I wrote it. Kc equals to concentration of SO3 square over concentration of SO2 square into that of oxygen. How many concentration terms do we have on the numerator? Look at the numerator. How many concentration terms do we have in the numerator? Square. So unit of the top equation will be mole per dm cube square. Am I right? That's for the top. What about the one that for the down? Mole per dm cube raised per 3. Do you agree?
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, a gel tech do have a private tuition. So By my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at agiletech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E levels as well, um, and also for the Edexcel. So we have for the Cambridge E levels and Edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is, what I've discussed with the sales team is, we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the sales team. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, when this is in 2026, when this is 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
I don't understand what's happening there.
This means concentration. This means concentration. How
Yes.
many concentration has the numerator? Square of it. Each concentration is mole per dm cube. What is
Okay.
now concentration square? Of course, mole per dm cube square.
Mm-hmm.
You didn't get that?
Yeah, I got it now.
Now, look at it. Upper process, N2, 3H2, 2 ammonia. Are you there? Then
Yes.
Kc will be concentration of ammonia square, that of nitrogen times that of hydrogen raised by 3. The guy on top, the unit is mole per dm cube square, because of this square. The one that is down, mole per dm cube raised by 4. Do you agree? Hello?
Um, Raised to power 4.
This is 1, this is 3, so it's 4.
Oh, okay. Yes, I get it.
Are you getting it? Then this guy
Yes.
cancel 2 of them here, remaining 2 down. So unit should now be what? 1 over mole per dm cube square. Am I right? So
Yes.
it now become 1 over mole square dm to power minus 6. Am I right? The
Mm-hmm.
final unit now be what? dm6 per mole square. Do you agree?
Yes.
You are doing maths? Are you a math student?
Yes, I am.
Okay, good. Are you sure you understand this?
Yes, sir.
Good. Now, in terms of, if I now want to write KP for this same equation, KP, let me write KP now for this same equation. KP will now be what? Partial pressure of ammonia square over partial pressure of nitrogen times partial pressure of hydrogen raised by 3.
Uh-huh.
Suppose the partial pressure is given to you in atmosphere or in Pascal or in kilopascal. Let's say it will not become what? Atmosphere square over atmosphere raised by 4. Do you agree?
Yes.
So it now become what? 1 over atmosphere square. Now become per atmosphere square. Do you agree?
Okay.
Are you sure you understand that?
Yes. So that squared is where is it coming from exactly? Because we're just putting.
So
I
unit of
understand the
Kc
demono.
varies from equation to equation. Kc
Oh,
and
okay.
Kp does not have a fixed unit. It depends on the equation given to you. Do you get?
Mm-hmm.
Sometimes Kc has no unit. Look at this. H2, I2 gas to give 2Hi gas.
Okay.
What's Kc? Concentration of iodide square over
Mm-hmm.
that of hydrogen, am I right, into that of iodine. What unit here? Mole per dm cubes square, am I right? What about the
Yes.
low one? Mole per dm cube also square, am I right?
Mm-hmm.
So that means no units.
Okay.
So sometimes Kc has no unit. It depends. The equation vary from one to the other. Is that okay?
Yes.
Are you sure you get that?
Yes, I do.
Now, what about this guy? Can you write Kp for this guy? What's Kc here? Just the concentration of carbon dioxide. That's all. The other guys are solid. We don't involve solid. And the
Just
unit is mole
guess.
per dm cube. What's Kp? Partial pressure of carbon dioxide, which can be in atmosphere, which can be in kilopascal, which can be in pascal, depending on the one they give you. Is that okay?
Yes.
So do not involve solid substances in both Kc and Kp. Kc involve both gases and aqueous,
Yes.
but Kp involve gases only. Is that okay?
Yes.
I know units, so we are done with this. Now, can you read, please?
Please note that solids and liquids are omitted from both the concentration-based Kc and pressure-based Kp equilibrium constant expressions. In Kc, both aqueous and gaseous substances appear as molar concentrations. In Kp, only gaseous substances are involved.
Is that okay? I think that's fine. Now, equilibrium moles, equilibrium concentration, mole fraction, and part. This is a major thing you are learning this topic now. It's a real thing. It's a, can you see that we're doing calculation? It's a real thing. It's a real thing. It's a real thing. So let's go by it. I will not rush you. I will take my time. I'll read myself.
Okay.
Now, he said under certain this is a question. Under certain conditions, 280 grams of nitrogen, 40 grams of hydrogen were mixed together and allowed to reach equilibrium. Full stop. In a what? In a 2 dm cube reaction vessel. That's the volume of the container. At equilibrium, 136 grams of ammonia were present. That's the equation for the. He now said, one, find the mole of each substance present before equilibrium and at equilibrium. Number two, determine the equilibrium concentration of each component gas. Number three, write expression for Kc. Number four, calculate the value of Kc, including the unit. So let's go and look at number one. I have done it down. Now, solution, look at number one. Okay, you know what? Let me open this thing twice. Hold on. So I'll be
Okay.
switching. I can be switching. Hold on. Just hold on. Okay, so this is very, let me do like this. Hold on. This question. Let me go to the mask email. Yeah. Look at the answer. Look at the question. So we are told that 280 grams of night. Oh, that should be. Oh, how do I write that? Okay. Let me sit down. Yeah, let's go. Are you there? 20 grams
Yes.
of nitrogen, 40 grams of hydrogen. Look at the mole. So, mole at the start. How do you find mole of gas substances given in mass?
Mass.
Mole
Mass
equals to mass
given.
over molar mass. So,
Mm.
mole equals to mass. Molar mass of nitrogen is not 14. Because nitrogen is N2, not N. So, molar mass of nitrogen is 28. So, what was the mole of
It's
nitrogen at the start? 10 mole.
10.
Mole of hydrogen at the start, 22 mole. Ammonia was not there at the start. Sometimes ammonia could be there from the start. You have to do what they give you in the question. They tell you that 10 mole of nitrogen, 20 mole of hydrogen, and 0.5 mole of ammonia were allowed to reach. That means ammonia was there from the beginning. Do you get?
Mm.
Good. Now, and I told you that what was the mole? And I say at equilibrium, 136 grams of ammonia were present. Find that in mole also. Mole at equilibrium, look at ammonia, is here, 136 over 17. What is the mole of ammonia present at equilibrium?
8.
What is the mole of ammonia present at equilibrium?
That's 8.
Thank you. What was the mole of ammonia at the start?
0.
So how many mole of ammonia were formed from start to equilibrium? How many mole were formed?
8. 8 were formed.
Thank you so much. Thank you so much. I like that. You are getting it faster, faster. So nitrogen was 10 before. Hydrogen was 22. Ammonia was nothing. Now, ammonia was now 8. That means from that time when we started till the point of equilibrium, 8 moles of ammonia were formed. Is that correct?
Mm.
Now look
Yes.
at the mole ratio. What's the mole ratio here? 1 to what? 1 to what?
2.
Thank you. When 8 moles of ammonia were formed, how many mole of nitrogen must have reacted?
1.
Should I say that again? The
Yes,
ratio
yes.
is ratio 1 to 2. Don't forget. For
Mm.
every 1 mole of nitrogen that reacts, 2 mole
Oh,
of ammonia
2.
will be formed. For
Okay.
every 1 mole of nitrogen that reacts, 2 mole
Mm.
of ammonia will be formed. Now, if 8 moles of ammonia were now formed, how many
Mm-hmm.
mole of nitrogen must have reacted?
4.
So if it was initially 10 and 4 reacted, how many will now remain now? If nitrogen was initially 10 and you
Mm.
said 4 must have reacted, how many will now remain at equilibrium?
If nitrogen was 4.
I'll say it again. Can you listen? I'll say it again. I will say
Okay.
it until you grab it. Just listen.
Okay.
Ammonia was initially 0. Ammonia is now 8. So how many mole of ammonia were formed at equilibrium? It was 0 before, so it's 8.
Mm.
So 8 moles of ammonia were formed at equilibrium. Do you agree to that?
Yes.
Now look at the mole ratio of 1 to 2. What does that mean? Nitrogen and ammonia. When 1 mole of nitrogen reacts, 2 moles of ammonia are formed. Do you agree?
Yes.
When 1 mole of nitrogen reacts, 2 moles of ammonia are formed. Is that okay?
Yes.
So if 8 moles of ammonia were formed now, how many mole of nitrogen must have reacted?
If 8 formed. Sir, could you
8
please repeat your?
if
Mm-hmm.
when 1 mole of nitrogen reacts, 2 mole of ammonia will be formed. If 8 mole of ammonia are now formed, how many mole of nitrogen must have reacted?
4.
4. How many mole of nitrogen was there at the start?
1.
Look at the mole at the start.
Or 10.
I'll start all over again. When 1 nitrogen reacts, 2 ammonia molecules will be formed. From this way they gave us now, ammonia at the start was 0. Now ammonia at equilibrium is now 8.
Mm.
That means 8 moles of ammonia were formed at equilibrium. So
Mm-hmm.
based on the mole ratio of 1 to 2, if 8 moles of ammonia were formed at equilibrium, how many mole of nitrogen must have reacted? You said 4. Ratio 1 to
Mm.
2. So 4 to 8. Is that correct? So 4 nitrogen must have
Yes.
reacted. Am I communicating? If 4
Mm-hmm.
nitrogen has reacted and
Mm-hmm.
nitrogen was initially 10, how many nitrogen will now remain now? 10 minus 4.
Oh,
That's 6.
6.
You get?
Yes.
Now, can you relate nitrogen and nitrogen now? Now, I could have related, listen, pay attention here. I could have
Yes.
related ammonia and hydrogen. I mean, it is ratio 2 to 3. It's not easy to relate. Or is somehow, let me just relate 1 and 3. Maybe you know how many nitrogen reacted. How many nitrogen do you say reacted? How many nitrogen
We said
reacted?
4.
4.
We said
So
4.
4, thank you. 4 nitrogen reacted. At the same time, based on ratio 1 to 3 for hydrogen and nitrogen, 1 to 3. If 4 nitrogen reacted, how many hydrogen must have reacted at the same time? That would be 12.
Mm-hmm.
Ratio 1 to 3. 4 of this reacted. 12 of this also must have reacted. Do you agree to that? Times 3.
Mm-hmm. Yes.
So if 12 now reacted and it was initially 22, how many will now remain at equilibrium? It should be 10.
Yes.
It's somehow, by the time you explain to 2, 3 times, you get it, don't worry. It's somehow technical. But if you pay attention, you get it. I'm sure you get it if you pay
Mm-hmm.
attention. Should I explain it again? I want to be sure you
Yes, sir.
understand it.
Okay.
So I can't take any chances because it's a major thing under this topic. I will start again.
Okay.
You were told that ammonia at the start was 10. Hydrogen at the start was 22. There were no ammonia there at the start. But
Mm-hmm.
nitrogen was 10, hydrogen was 22. They now said at equilibrium, they found 136 grams of ammonia. We cannot relate mass, we can only relate mole. When substances react, they do so in moles. So if ammonia was initially 0, and now found 136 grams, look at it here, they gave you the question. They said at equilibrium, 136 grams of ammonia were present. But ammonia was not there in the first place. That means 136 grams of ammonia have been formed. Is that okay? That's the amount that have been formed. We convert that to mole, we now go to the 8. We say, okay, it's 8 mole of ammonia formed at equilibrium. You now say, so we now begin to relate that, okay, this one is ratio 1 to 2. When one nitrogen reacts, 2
Mm-hmm.
ammonia must be formed. So if 8 ammonia were formed, the meaning is that 4 nitrogen must have reacted. Do you understand that?
Yes.
If 4 nitrogen now reacted, nitrogen was initially 10. If
Mm-hmm.
out of 10, 4 reacted, how many will now remain? 6.
Yes.
Now, let's now relate nitrogen and hydrogen now because it's easier to relate 1 to 3 than 2 to, we could have related this guy and this guy. I could have related what again? Ammonia and hydrogen. But since I've gotten hydrogen, it is easier and convenient for me to relate 1 to what? 1 to 3. Do you agree to that?
To 3.
So
Yes.
we now said 4 nitrogen reacted now. That is why 6 nitrogen remains. If 4 nitrogen react at the ratio of 1 to 3, 4 nitrogen reacted, then how many hydrogen must have reacted at the same time? It will be times 3.
Oh. Mm.
So 12 hydrogen must have reacted. Out of 22, if 12 react, remaining 10. That's how I got my 6 and my 10.
Okay.
It's somehow technical, but I bet you if you go over it and look at it again, you will
Mm-hmm.
get it.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Agile Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have um, you know the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at agiletech@gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E levels as well, um, and also for the EdXL. So we have for the Cambridge E levels and EdXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time. Even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you. And the good news about this is what I've discussed with the sales team is we've tried as much as possible to see how we can subsidize the amount according to countries, so it doesn't really look very, very heavy. Okay, so this is really important. Yes, we do charge in pounds, but again, we try to be as much as possible considerate to your countries, and we don't just skyrocket the price. No, because at the end of the day, we know how it feels, and we really want you to actually get the best of service, and again, be able to afford it from the comfort of your home. So again, Agile Tech private tuition is currently ongoing. You can enroll yourself for the IGCSE, and then for the E levels. Again, for the IGCSEs, these are the subjects, and for the E levels, these are also the subjects. So again, what are you waiting for? Just send an email to the system. If you're an IGCSE student preparing for IGCSE, if you're watching this in 2025, watching this in 2026, watching this in 2027, we're currently ongoing, and this is actually a good time for you to actually explore, and then get it tailored to your own needs. So trust me, you don't want to miss out.
Okay.
If I need to this when I'm done, this thing I said now, I explain to you, I will explain it. I will say it in what I will record it on my phone and I'll put it on the classroom for you to download and go. I expect for this number one, so that when you get it 2, 3 times, you will be able to get it better. Is that okay?
Yes, that's fine.
Thank you. Now, so that's the amount I'm going to now say. So mole at the start 10,22,0. Mole
Mm.
at equilibrium 6,10,8. Now, what is now the concentration at equilibrium? How do you find concentration? It's not mole over volume, right? But
Mm.
the unit is mole per dm cube, right? The
Yes.
mole I've got now. The volume of the Solo system is what? 2D. Where is it now? I think it was the volume. Where is it? 2 dm cube reaction vessel. 2 dm cube. So go and find the concentration. That will now be mole over volume 3 mole per dm cube. Mole over volume 5 mole per dm cube. 8/2 4 mole per dm cube. Is that okay? And
Yes,
I'm going
that's
to write Kc will now be, based on this equation, concentration of ammonia square over that of nitrogen multiplied by that of hydrogen is per 3. Is that okay? Kc will now
fine.
be 4 square over 3 times 5 raised per 3. That's Kc for you. And that's unit
Okay.
for yours. Is to get Kc is not a problem, but to get the value for Kc is what will take our time. Getting Kc is not a problem. But we need to get the value we are going to use for our Kc calculation. Is that okay?
Mm.
Does it make any sense, class?
Yes, it does.
Thank you. Thank you so much. Thank you so much. Now let's go. So that's how to get Kc. Now, question 2. Let's go to question 2. He said, calculate the mole fraction for each of the substances present at equilibrium. The same equation. Let's go back. Don't forget mole. I just came here to copy this. I came to copy this here. I came to copy this. Mole at equilibrium. Is that okay? 6, 10, 8. Same question. Same question. 6, 10, 8. I've written. Now said, how do we find mole fraction? Mole fraction equals to individual mole over total mole. That's mole fraction. Mole fraction of nitrogen will be mole of nitrogen over total mole. Here, the total mole is what? Total moles will be 6 plus 10 plus 8. That will be what? 24. That's total mole. Is that okay? So what is the mole fraction of nitrogen? 6 over 24. Mole fraction of hydrogen? 10 over 24. Mole fraction of ammonia? 8 over 24. Do you understand that? Mole fraction equals to mole of a substance over total mole. Mole fraction of a substance equals to mole of that substance over total mole. Mole of the substance over total mole. Are you listening to me?
Yes, I am.
Do you get that?
Yes, sir.
Now, let's now go on to partial pressure. How do we get partial pressure? Is now mole fraction times total pressure. Let's go and see. He said, look at, can you read number 2? Read it, please.
Number 2, okay. Calculate the mole fraction of each of the substances present at equilibrium.
You have done that. B.
Work out the partial pressure of each of the equilibrium gases, given that operating pressure is 144 atm.
Total pressure is 144. So having got the mole fraction for each of them, partial pressure is now mole fraction times total pressure. Is that okay?
Yes.
Mole fraction equals to your fraction. If you have 10 boys and 16 girls in a room, what is the mole fraction of the boys? It will be 10 over 26 times total pressure in the room. What is the mole fraction of the girl? I mean, mole fraction of the boys will be 10 over 26. Mole fraction of the girls will be 16 over 26. Is that okay? So your mole fraction equals to the mole of each individual substance over total mole. Is that okay? What is now partial pressure? Partial pressure, I can write it here. Partial pressure equals to what? Mole fraction times total pressure. Is that okay? I didn't write it there. I'm writing. Is that okay? So in this case, it will be 0.250 times 144 times this and this. You have got your partial pressure. You can now go and do Kp equals to partial pressure of ammonia square into partial pressure of nitrogen into partial pressure of hydrogen raised to 3. Now put in the values, you get your answer. Is that okay?
Yes.
So you must know how to calculate mole fraction and partial pressure. You must know that. Now let's go. Can you read?
Note that when K has no units, then the moles of substances present at equilibrium can be used to calculate Kc or Kp.
Can you stop there? What do you mean by when K has no units? Look at this. They told you, they said, yeah, look at this. Said, okay, let me do it like this. 20 moles of I2, 20 moles of H2, and 2 moles of HI were kept in a 0.5 dm cube container, were put in a 5 dm cube container and allowed to reach equilibrium. Are you there? At maybe 45 degrees Celsius, full stop. Now say number one. Now at equilibrium, how to do at equilibrium, comma, I'm coming in 16 moles of HI were found. Yeah, now that's right. The equation is H2 gas plus I2 gas. The hydrogen you used was gas, HI gas. Hydrogen is a solid under room condition, but the one they used there was gas. So 2HI gas. You know, I didn't sublime, even at room temperature. Let's make it 85. Now, yeah, let's do this. Can we do this together? Are you there? So can we write
Yes, sir.
mole at the start? We do one by one. Mole at the what? At the start.
Okay.
This guy was 20. No, is it 20? Yeah, 20. 20. Was HI there at the start?
HI, no, it came after. It wasn't at the start.
How many? 2. It was there before. 20 moles of I2,
Oh,
20
and 2
moles of
moles of
H2, and 2 moles of HI. So it's not always true that there won't be any product at the start. It's not always true. Sometimes from the start, they put some product there. Is that okay? And if the student don't wash out, we will now miss out that one. We will not remember to add it, and we will get it wrong. Now, what is now the mole at equilibrium? Moles at equilibrium. Which one they give us? Which one they give us? They gave us what? They said at equilibrium 16 mole of HI were found. This guy is now 16. You have to find this and this. Yeah, what will be the mole of H2? How do you find mole of H2 for what we have done today? How do you find mole of H2 at equilibrium? Yeah.
we look at the ratio. So that's 1 to 2. So we
How many
divide.
mole of HI were formed at equilibrium to start with? How many moles of H? 16 mole were found. But how many moles of HI were formed at equilibrium?
That's 14.
Thank you so much. 14. We're now going to look at the mole ratio now. So you have to look at, first of all, how many moles were formed at equilibrium, were formed.
Okay.
Not the one that were found, because some people have been there before. How many moles were formed? 14 were formed.
Yes.
So based on that 14, when this guy is 2, this is supposed to be 1. If he is now 14, this should be what? It should be 7. Am I right?
Yes.
That means 7 moles of I2 must have reacted. Do you agree?
Yes.
Remaining 13.
13 at equilibrium.
Is that okay? Same
Yes.
thing with H2. Same result to 1, 13. Do you agree?
13. Mm-hmm.
Now, I am supposed to find equilibrium concentration. But look at this KC. The case for this reaction, will it have a unit or not? The KC, will it have a unit or not?
I don't really understand the case we take.
Let me help you. Look at KC. Concentration of HI square into that of H2 into that of I2. Will KC have unit or not?
It won't.
What is it? It won't have unit, am I right? Therefore, don't bother to go and be calculating equilibrium concentration. Come back. I said, look at it. I said, note that when K has no unit, moles of substances present at equilibrium can be used to calculate Kc or Kp. In such situation, it is needless to calculate equilibrium concentration or even partial pressure. There's no need to calculate it. No. Yeah. So the numerical value of moles of substances at equilibrium are put directly into the equilibrium expression to calculate K. You don't have to go and calculate. For me, just write, what's now K? Just write Kc. Because this guy has no unit, just write Kc. Concentration of HI square. It should be concentration, not mole. It's supposed to be concentration. that of H2 and I2. We now say, because KC has no unit, since KC has no what? No unit, right? Therefore, KC, just use mole, it should be what? 16 over what? 13 what square. All right, get your answer. That's the answer.
Okay.
When KC has no unit, look at what we did here. When we got mole of each substance, we went ahead to calculate concentration of each substance to get KC. Are you there? Come back again. For this one, when we got mole of each substance, to calculate Kp, we have to go and get mole fraction, then partial pressure again. But when Kc has no unit, there's no point calculating all those ones. You get the same answer if you do it. Do you get it? There's no point wasting time calculating those. You get the same answer. When Kc has no unit, all those partial pressure will cancel out themselves. You don't you just use mole and calculate your Kp. Does that make any sense? When Kp
Yes.
of Kc has no unit, you know better to go and be calculating equilibrium concentration and mole over volume. If you are giving the volume, just ignore the volume.
Okay.
Go to mole over volume, or let me go and find partial pressure. There's no point. If Kc has, you get the mole of each of the substance involved. Just putting that into the Kp expression, you get to the same answer. Is that okay? There's no way wasting time calculating the other one. Does that make any sense, class?
Yes, it does.
Thank you so much. So that's about that. Is that okay? So now
Mm-hmm.
I can prove it to you mathematically that. Okay, now look at here. What do you get? Will you have a calculator?
Yes, yes.
What do you
It's
get? What's the answer?
0.0946.
0.0946. No unit. Now, what if somebody say, no, I don't believe. Let me go and find it. Okay, let's go and find it. Concentration at equilibrium. The unit, the volume of the reactor was 5 dm. It should now be what? 13 over 5. Am I right? This one also be what? 13 over 5. This one will be what? 16 over 5. Are you there?
Mm-hmm.
That is the concentration at equilibrium. Is that not so? What will not be Kp now? Let's do another case now. We are calculating another case now using concentration. We want to know whether the Kp calculated by using mole or the one calculated by using, whether they have the same value. Do you get the point now? This is Kp calculated using what? Moles. Let's now do another. Normally, we are supposed to calculate Kc based on concentration, not moles. We are supposed to calculate Kc based on what? Concentration, not moles. But here, I'm not saying that when Kc has no unit, there is no point wasting time to calculate concentration. Just use mole, you get the same answer. Is that okay? Let's prove it now. Yeah, let's go. What's now Kc here? Concentration of ammonia square to that of hydrogen raised by 3 and nitrogen. Is that okay? What's ammonia? Ammonia is 16 over 5. It will not be 16 over 5.
Squared.
It's not ammonia I'm using, it's HI. When did I write ammonia? Oh my God.
How many is it?
HI. The equation we are considering is HI now. It's not ammonia, it's not HI. It's the equation we are considering, right? It should be concentration of hydrogen into iodine over HI square. Am I right? HI is what? 16 over 5 square. Where about no, it should be no,
It's
it
16.
should be the other way around. Sorry. Am I right? It should be HI square, the products, am I right? Over H2 into I2. Is that correct? What's HI? 16 over 5. What's H2? 13 over 5. What's I2? 13 over, so that would be 13 over 5 also. Do you agree?
Yes.
We are calculating another case now using the concentration we are supposed to use. I'm now telling that what we get and what you get will be the same thing. Let's go on. Yeah, what would it be? This will now be what? 16 over 5 square over what? 13 over 5 square. Am I right? What would that be? To be what? 16 square over 5 square times 5 square over what? 13 square. Is that not so?
Yes.
Oh, sorry. I didn't put square here. Please come back here. I didn't put square here.
Wait.
Put square when you are doing. Do you put square when you are doing that? Do you put square?
Oh, wait, let me confirm.
Please we'll do it again. It should be 16
Okay.
square over 13 square.
Okay, and then we get 1.515.
1 point what?
1.51.
1.51. Now,
Mm.
can you now see now? Look at this. So what will happen here? This cancel this. First, it has gone back to what we got here. Do you agree? What we got here is what? Look at what we got here. 16 over 13 square. You know the same thing we got here? Are you there?
Yes, I am.
So when KC has no unit, the volume will eventually cancel out. When KC has no unit, the volume will eventually cancel out. So there is
Okay.
no point calculating concentration. Just use mole and calculate your KC. Use mole and calculate your KP. There is no point calculating concentration or partial pressure. There's no point. It's a waste of time. It's only a multiple choice. Just ignore it. Maybe you
Yeah.
see KC as no unit. Just don't try use mole to calculate your KC. Get the
Okay.
same answer. Is that okay?
Yes, that's fine.
Thank you so much. Now, I will solve more questions for you, but I'm going to the other part of the topic. Let's go. Can you read?
Equilibrium processes in chemical industries.
Paper
Have a
process.
process.
Go
Hmm.
on. Hydrogen plus nitrogen to give ammonia. Enthalpy change is minus 92 kilojoule per mole. What are the operating conditions for this reaction? Yeah, go on. Temperature between 450 to 550. Just write 450 in the exam. Don't write range. You write any value within that. Just write 450 in the exam. Is that okay?
Okay. Okay.
Pressure between one, just write 200 or whatever, or 150. Just write any value within that range. Is that okay? Catalyst is what?
Okay.
Finely divided ion. Is that okay? Now, this is an industrial process. The forward reaction is exothermic. We want to get maximum amount of ammonia under the partial rate of reaction. Now, if you get large amount of ammonia and the rate of reaction is too slow, it won't pay you. You have to pay your, let's say now, instead of getting within 3 months, you now do it for 8 months. So you get larger amount of ammonia. You have to pay your workers for 8 months. So a chemist or an industrial engineer or industrial chemist or chemical engineer, what they do is that they are looking for means to get large amount of the product within a short time. Okay, to maximize their gain. They want to get large amount of the product, that is yield. Within a short time, that is rate, to maximize their rate. Is that okay? Now, can you read the
Yes.
story? Can you read it?
The forward reaction is exothermic. A low temperature gives a higher yield but a slower rate.
Do you agree to that? If you use low temperature, the forward reaction is exothermic. If you use low temperature, equilibrium shift to the right. Do you agree?
Uh,
What you learned there was, come and see what you learned. Let me show you what you learned. For temperature, for endothermic reaction to go forward, you need an increase in temperature or a high temperature. Endothermic to go forward need high temperature. This one is now exothermic. To go forward, we need low temperature. Do you agree to that?
yes, I do.
But I have a problem. If you use a low temperature, the rate of reaction will be too slow. You will now get large amount of ammonia, but over a very long period of time. It will not pay you. As an entrepreneur, it will not pay you. The equilibrium position we are talking about is affecting the amount of product, how fast the reaction occurs, is a function of rate of reaction. Is that okay? Now,
Yes, but
do you get?
yes, I do.
If I use low temperature, I'm going to get large amount of ammonia because equilibrium will shift to the right, but at a slower rate. And if I use high temperature, equilibrium will shift to the left. Am I right? I will get a lower yield, but at a faster rate. So there's a problem now.
Yeah.
Temperature is high, lower yield, faster rate. Temperature is low, higher yield, but slower rate. Therefore, a compromised temperature of about 40 degrees Celsius, which is not too high and not too low, is usually adopted to give a fast rate and a reasonable yield. Do you get the point?
Yes, sir.
If temperature is, if they ask you, why was 40 degrees Celsius, why was it chosen? Or why can't we choose higher temperature like 1000? Or why can't we choose low temperature like 100? Tell them that when we use low temperature, the amount of the product we're going to get will be much, but it will be at a very slow rate. When
Yes.
we use high temperature, the amount of product will be what? Will be slow, but at a what? At a fast rate. Let me get an instance. Your uncle promised to give you when you're in Jersey school, he promised to give you $1,000. No, he promised to give you. I'm talking about rate and yield. Rate and yield. I want to explain to you. Or no, let's do this way. Let's do this way. This is a limestone at your backyard. It's limestone. You now call a chemical engineer. He said he can get you. He said he can get you 10,000 bags of cement.
Mm-hmm.
He said he will do that within 4 months. He said he will get you that. How about he say no, 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 no. He said I can give you 50. I can give 12,000. He said wow. Then you want to go for the 12,000 guy? He said I can give 12,000 bags of cement. That's the first guy. Most of the limestone is wasted. He didn't utilize them very well. Most of them is wasted. Is that okay? I said I can get 20 bags. That's how long? He said in I don't know, in 6 months. We are now engineer A, engineer B. What is rate A? Rate A is equal to what? Number of bags over time. That is 2,500 bags. Am I right? Per what? Per month. Am I right?
Mm-hmm.
10,000 in 4 months means 2,500 per month. Is that okay? What's rate B? That be 12,000 in 6 months. That be 2,000 bags per month. Am I right?
Mm-hmm.
Question 1. Engineer A and engineer B. Which one has a faster rate?
Yeah.
Engineer
A,
A and engineer B. Which one has a greater yield?
a greater yield. A.
No, B. Yield means how much will you get at the end of the day? The guy is out of this time, so he said I will get 200,000, 10,000 back. That's all I can get. Others come with. The guy said I can get 12,000. So engineer B has greater yield, but at a slower rate. Are you there?
Oh, okay. Yes.
Engineer B has a greater yield, but at a slower rate. So
Mm-hmm.
engineer A has a faster rate, but a lower yield. So which one would you go for? I'll just say, okay, I'll just say, okay, engineer A. I will just say, I'll call it, I'll say engineer what? Engineer B. I will now say, you know what? Can you get me these 12,000 bags in maybe 4.5 months? So I know that from what engineer B said, we can get 12,000. That we can get it. He knows what he's doing. But the time taking is too long. I don't want that time taking too long. I can't wait. I'll say, can you help us to do 12,000 in 4.5 months? If you do that, let's see what they're going to get. Yeah, let's get to be what? 12 divided by 4.5, what do you get?
Let me see. 12. 12,000.
12,000 divided by
It's
4.5.
2,666.
Can you down 60? Can you now? At the end of the day, I want to get. I know that engineer. Let's say 5 months. Let's say 5 months. Can you do divide by 5?
In 5 months, okay.
Mm.
2,400.
Thank you. 2,100 bags per month. Can you see now?
Amount.
I'll go and get. Now look at the one. Look at the new one. I said this is what I want to. Engineer A and B. I don't believe in both of you. This is what I want. This is what I want. I want that 12,000 bags we want to get. But in 5 months. So at the end of the day, my rate will be 2,400, and my yield is still high. Do you agree? I want to eat my cake, have it. I want to have both of them. Higher yield, higher rate, greater yield. I want to have both of them. So that's what they do. Is that okay? So when you come to
Yes.
other process, high temperature, the forward reaction is exothermic. And then takes it backward. So lower yield of ammonia. But with high temperature, you get a faster rate of reaction. Again, for this same guy again, if you use lower temperature, you get large amount of ammonia, but at a slower rate. Therefore, you have to go for a temperature which is not too high, which is not too low, to help you so that you can balance both of them. Do you agree? So strike a balance between rate and what and yield. Is that okay? That's why we choose that temperature. If they ask you why the question is why 450 degrees Celsius? Why not higher? Why not lower? These are the reasons we're going to give them. We say, oh, the forward reaction is exothermic. Oh, when it's too low temperature, the rate will be very slow. We are going to get higher yield, though. And when it's too high temperature, the rate will be fast at a lower yield. However, we now say that to balance rate and yield, let's go for a temperature which is not too high, which is not too low, e.g., 450 degrees Celsius. Is that okay? We done that. Now, what about pressure? Why do we use the pressure of 200 atm? That's a high pressure. Yeah, go on. Come and read for us. Why do we use high pressure? Can you read?
There's a decrease in number of moles of gaseous substances from reactions to products. An increase in pressure, therefore, favors forward reaction, giving a good yield of ammonia. A high pressure also contributes to a fast reaction rate.
Thank you. Look at how many moles of gas do we have on the product? 2. How many moles of gas here? 4. So high pressure, where will it shift to? Lower volumes. It takes you right. Do you agree? So this guy, high pressure favors us. High pressure gives us a high yield of ammonia. High pressure also increase rate of reaction. Do you agree? It helps us. So the pressure guy favors both of, unlike temperature that is causing confusion. Look at what I've said. Temperature is causing confusion. The pressure here, high pressure favors both rate of reaction and yield of the product. Do you agree? It favors us. So we have a good high pressure and it's good for us. Now, why do we use catalyst? Can you write? Can you read?
The catalyst increases rate by lowering
Activation. That's EA is what? Activation energy. It's allowed in the exam. You can write it that way. It's allowed anywhere in the world. EA, capital E, small a, is called activation energy. Activation energy is allowed anywhere in the world. So when you are writing, you don't have to write it fully. You can just write EA. It could be capital A, but the A must be subscript. Is that okay? It could be capital A also. You don't have to be small. It can be capital A if you like. But the A must be a subscript. EA, that is what? Activation energy. So let's go. Catalyst increase rate by lowering activation energy. Thus, reducing the time taken to reach equilibrium. If there's no catalyst, it takes a longer time before they reach equilibrium, right? Catalyst short in time taken to reach equilibrium. And in finely divided form, when the catalyst is finely divided like powder, the catalyst is more efficient. The catalyst, however, has no yield on the product. Am I right? So the catalyst, however, has no effect on the yield of ammonia. The yield is about, is that you know the yield though? the yield of ammonia is about what? 15 to
15
20.
to
That means
20.
so the catalyst, however, has no effect on the yield of ammonia. The yield is about 15 to 20%. What does that mean?